Good morning, Darcy. So your work here, friend, looks great. You're not wrong at all. But what you have to do now is you have to reduce those down, right? Because here's what you did. You applied the flipped root trick. So we got x to the 4/3. I'm just writing it out a little better. Times y to the 5/3, right? Which is perfect. But notice that each of these fractions are improper fractions. They're worth more than one. So what you would have to do is kind of subtract out. Let me get a different color here. We'd have to subtract out like 3/3 from each one of these, right? And that would give you like 1x plus this x and 1/3. Do you know what I mean? Because that's like x to the 1, and this is like 1 to the 1. So you have to do that. A slicker way, and again, this is not the wrong way at all. It just makes an extra step for you. My preferred way, just as an opinion, is what I would do is I would just say, okay, what's the biggest perfect square, or in this case 3, right? Because that's what we want. What's the biggest x cubed I can get out of that? Well, it's x cubed times x, right? That's giving us the reverse of the product rule. 3 plus 1 is 4, so we're good to go there. Get out of there, Windows. And I'll do the same with the y. So I need a y cubed, and that's going to give me a y squared left, because remember, that still has to add up to 5. Once I'm there, I can just take the square root of that, because it's a perfect cube. By the way, we're looking for a cube root, sorry. Cube root of that. So that will come out. I can just evaluate that. That's going to equal x. This is going to equal y. Remember that when we have the index and the exponent being the same, they cancel off. And then all this other stuff that's left, this xy squared, that will just stay under the cube root symbol. We'll just leave that, xy squared. You could put the 1, but it looks cooler if you don't. I don't want you to get made fun of, right? So that already gives you a nice clean, and by the way, that's like the cube root up here, okay? So that should be how you get that answer. It's a nice slick way. Now down here, if you didn't do that, if we just wanted to keep rolling, check out what would happen. We'd have, that should be a times. This is going to be a y, and then this will be a y to the 2/3, right? I'm just subtracting that off. So again, now we get the x and the y. I'll just write those up here neatly. And then we have this 1/3, 2/3, which again, we would then have to flip back in using the flipped root trick, right? You see where that comes from? Like that. So you could still get there, you're just making 2 extra steps, really. That's just my take. I like to do it my way, but if you want to keep rolling this way, that's super cool too. Hope that helps.